We've had quite a few lessons looking at quadratic equations, quadratic functions, quadratic graphs. And in this section, this next couple of sections, what we're going to look at is using those to actually solve real-life type problems. And we're going to see that we're going to end up using some formulas here. We're going to be reading word problems, reading paragraphs, encountering real-life type situations, and then saying, how can we get this into a mathematical equation? And it's going to turn out that all of our equations will be quadratic equations, so we can use our quadratic methods to solve. And we're going to be using, we've already used the perimeter formula for a rectangle is 2 times the length plus 2 times the width. We're also going to see in this section that our area formula is length times width. We're going to use that formula. And we're also going to use what's called the Pythagorean Theorem. And what the Pythagorean Theorem says is that if we have a right triangle with sides of length A and B, and the hypotenuse, that's this crossways one, is called the hypotenuse, is C, then it's true, always true, that A squared plus B squared equals C squared. So those are some formulas that you need to memorize and to know. So let's say that we want to build a garden. A rectangular garden. With an area of 345 feet squared. We have 76 feet of fence. And let's say we're not worried about a gate or anything. We're just going to fence it completely in, just to make this more simple. What should the dimensions of the garden be? And we're going to see that it's going to be helpful to us to draw a picture. So let's say we have our rectangle. And when I say what are the dimensions of the garden, that means find length and width. That's what we normally call the sides of a rectangle. So we're going to have two variables. We're going to have L equals the length of the garden and W equals the width of the garden. So we're trying to find two numbers when we say dimensions. So if I write those on here, this is W, this is W, this is L, and this is L. And you can do it either way. You could have made the L the longer side and W the shorter side. It really doesn't matter. So now we know what we're finding and we have a picture. Let's see how we can use the information in the problem to solve this word problem, this application. We're given two pieces of information. We have an area of 345 feet squared. We also have 76 feet of fence. We have a formula for area, length times width. So that gives me an equation that, because I know area equals length times width, and I'm told in my problem that the area is 345, I have 345 equals L times W. Then I'm going to use my other piece of information, 76 feet of fencing. If the fencing just runs around the edge here. That amount of fencing is the perimeter. That means the same thing as perimeter. So we have a formula for perimeter, 2L plus 2W. And my perimeter is 76, so I can write 76 equals 2L plus 2W. So now what I have is two equations with two unknowns. And I can solve this using one of our methods, substitution elimination. And I think that substitution is going to be the easiest method. So what I'm going to do here is I'm going to solve this one for one of my variables. And I'm just going to go ahead and solve for L in terms of W. Pause the video, isolate L in this equation, and then turn the video back on. All right, so if I solve for L, I'm going to subtract the 2W, and then I'm going to divide everything by 2. Now I have L in terms of W, and I can substitute that back in for L in this equation. So 345 equals, and in place of this L, I'm going to put all of this. And then times this W that's already here. So now I can just solve this equation. And the first thing I'm going to do is distribute the W, and then I'm going to see that I have a quadratic equation in terms of W. And we've just spent the last 6 or 7 lessons, 6 or 7 videos on solving quadratic equations. So I want you to go ahead and distribute the W, and then solve for W using quadratic methods. Pause the video and solve for W. All right, so we see 345 equals, distributing the W, 38W minus W squared. Then I want to get this equal to 0, because I have this term, the W term. I want to get this equal to 0, keeping the W squared term positive. So I'm going to bring everything back over to the right. So I'll have W squared minus 38W plus 345, because the 345 stays where it is, equals 0. Then I look for common numbers, which I do not have any. I look for common variables, which I do not have any. And then I try to factor. So I have W here, W times W is W squared. And then I'm looking for two numbers that multiply to give me 345 and add to give me negative 38. Because this is positive, they both have to be negative numbers. So two numbers that multiply to give me 345 and add to give me 38. Let's see, I'm going to have to play around with that for just a little bit. And I see that I have 15 and 23. So I solve each of those. W equals 15. W minus 15 equals 0, so W equals 15. W minus 23 equals 0, so W equals 23. So I see that I have two different numbers. And when I look back at my original problem, I can see that if I have the two numbers, if I let W equal 15, and then I plug back in here 38 minus 15, I get 23. If I let W equal 23 and I plug back in, I get 15. So I actually ended up with both of my solutions here, but I can choose one of them, W equals 15, and then that tells me length equals 23. So W equals 15 feet, and length equals 23 feet. And based on my picture, actually, I probably should have chosen the other way around for the size of the edges, but it doesn't matter. You can use either one. Let's look at another example. Let's say that I have a poster. A rectangular poster has a diameter of 26 inches. And I know that the height of the poster is 14 inches more than the width. Find the dimensions of the poster. All right, we're going to do the same thing we did on the previous one. We're going to draw a picture and we're going to figure out what it is that we're trying to find. So I have a poster, rectangular poster. And on this one, it talks about the height and the width. So I'm going to call this H for height and this W for width. And on this one, it also tells me that I have a diameter of 26 inches. And remember, a diameter is from corner to corner, across like this, diagonally. Okay, I totally used the wrong word here. Should not be diameter, that's of a circle. I beg your pardon. This should be a diagonal. I used the wrong word. I'm sorry if I led you astray there. So the diagonal is going across corner to corner here. And I'm told that that is 26 inches. And what I'm trying to find are the dimensions of the poster, the height and the width. Okay. So now I need to come up with some kind of way of relating H and W and 26. As soon as I see this diagonal here, cutting this poster into a triangle, and because it's a rectangle, I know that's a right angle. As soon as I see that right triangle, I'm immediately thinking that I'm dealing with the Pythagorean theorem. Almost every time that you're dealing with a right triangle with a diagonal here, you're going to be using the Pythagorean theorem. So I also have another piece of information here. Actually, let's go back to this, the Pythagorean theorem. So I think about in the Pythagorean theorem, if I have my ABC, I have to think about what is replacing these variables A, B, and C. I cannot have A, B, C, and H and W all in the same equation. So in terms of this triangle, I'm saying that H squared plus W squared equals 26 squared. I'm going to do this in terms of H, W, and 26. But now I have two variables in the same equation. So I have to look back in the problem. Do I have any other information? the height of the poster is 14 more than the width. And I'm going to go ahead and write that out in words. And we're going to see how we can write that as a math equation by putting in variables and symbols. So we know the height is h. We know is equals 14 more than, and I need to be careful here because 14 more than is not 14 plus. 14 more than is actually plus 14. And what it's 14 more than is the width, w. So that gives me the equation h equals w plus 14. So now I can use substitution. I have what h is equal to. I can put it in place of h and rewrite this equation with a w plus 14. You see if you can do that. Pause the video and see if you can do that. I'm going to go ahead and rewrite this so I know exactly where I'm plugging in. The w plus 14 goes in place of the h. The w squared just drops down, and the 26 squared just drops down. And I can just use my calculator. 26 squared is literally just 26 squared. 26 times 26, which is 676. And now I have a quadratic equation in terms of w. I'm going to have to FOIL this out. Do not forget that when we're foiling here, we're doing w plus 14 times w plus 14. We're going to end up with 3 separate terms here. See if you can do that. Foil that out, rewrite the equation, and we'll see that's a quadratic equation. We combine like terms, and then we go through our quadratic quadratic steps to solve the equation. You go ahead and pause the video, solve this equation, and then turn the video back on. All right, if I FOIL out over here, I get w squared plus 14w plus 14w plus 14 squared, which is 196. So I have w squared plus 28w plus 196. Now be careful here because this w squared has to come down too. Don't forget that w squared equals 676. So I combine like terms and I have 2w squared plus 28w plus 196 equals 676. And I need to get this equal to 0, keeping the w squared term positive, so I subtract the 676. I get negative 480 equals 0. All right, now we need to keep doing our quadratic process. And remember, the next thing we do is look for any common numbers to divide out to make our numbers smaller. And we see that we have a 2, a 28, and a 480. All of those are even numbers. So I can divide out and cancel the 2. So I have w squared plus 14w minus 240 equals 0. Then I look for common variables. I don't have a common variable, so I can't do that. So now I try to factor. And because I have plain w squared with no coefficient now, I can just do w and w. And I'm looking for two numbers that multiply to give me negative 240 and add to give me positive 14. Well, if I think about this, 240 is 24 times 10. That's a pretty easy factorization there. So I'm going to try that. 24 times 10. One has to be positive and one has to be negative to give me the negative. And it does turn out that if I have a positive 24 and a negative 10, I get positive 14. So that is my correct factorization. And then I can set each of those equal to 0 and solve for W. And now think back here. We're looking at a poster here. So W has to be a positive number. It cannot be negative 24. So W equals 10 inches. And then I go back to where I substituted and found out what H was in terms of W. So H equals 10 plus 14, which is 24 inches. And I have solved my problem. In our next set of videos, we're going to look at using some quadratic applications where we're thinking about finding the largest or the smallest possible value, a maximum or a minimum, and we're going to see that that's